Hello everyone, today we're going to be talking about the equation of a circle. So we're going to be talking about graphing circles and also writing down the equation of them. So the first thing you're going to want to make take note of is this equation over here. So that's the equation of a circle. X minus h squared plus y minus k squared is equal to r squared. From this sort of equation, the little bits of information you need to know is that h comma k. So h comma k is the center. So those coordinate points will be the center point of your circle. And then r squared, the square root of r. So basically the value of r is basically your radius, so the radius of the circle. Now this figure on the left is a circle. It sort of looks like an oval, but since we know that approximately the center is at 0, 0, the distance from the center to each of these points is 6. Why? Because this is the point 0, 6. So from 0, 0 here at the center to 0, 6, it's 6 points, or 6 units. This is 6, 0, so the same thing goes from the center, which is at 0, 0, you go 6 units to the right. And this is the same thing as 0, negative 6, so this distance is also 6, and the same thing goes for this point over here, which is negative 6, 0, and this radius is also 6 points. So that's how you know it's a circle, because the distance from the center, which is over here, to each of these 4 corners is the same. Or any point on the circle, even over here, the distance would still be 6. That's how you know whether it's a circle or not. So in this equation, we're basically going to want to write the equation of this circle. So let's first try to note down h comma k. So h comma k is basically your center. From this graph, we know that this is the center, this central point, which is 0, 0. So that means h is 0 and k is 0. Now, one thing you want to make sure of is basically that in our equation up here at the equation of a circle, this is x minus h. But it's the reverse of h. So if h in this this part is negative, that means your h is going to be positive. So let's say that our center of the circle is 5, negative 2. That means our value of h is equal to 5. But when you're writing it in the equation, you're going to want to reverse the sign. So it'll be x minus 5 squared. Plus, we know that k is equal to negative 2. It'll become y plus 2, the whole squared. So you're basically just sort of like reversing the sign of that when you're putting it inside the equation. So that's one thing just to make sure of. In this specific example, it's 0. 0 is neither positive nor negative, so it doesn't really matter. Let's substitute this in our equation. So we have x minus h squared plus y minus k squared is equal to r squared. We know that h is 0, so let's substitute 0 here, and k is also 0. Normally, x minus 0, you normally never have to write it like that, so you're just going to write x squared plus y squared, and you're going to want to find r squared. Now, from our graph here on the left, we know that the radius is equal to 6. R is equal to 6. So that means r squared is equal to 36. So we're going to write 36 over here. And the final equation of this circle is this. So x squared plus y squared equals 36. So we're going to be trying another example here. Now, as you can see, I've sort of zoomed in on the graph and drawn a really, really super tiny circle. So the 4 sort of like defining coordinates of this circle are 0, 1, 1, 0, 0, negative 1, and negative 1, 0. From this, you can tell that the distance from the center, so in this case, the center of the circle would be 0, 0, so the origin to each of these points is 1. So that's your radius. The radius of this circle is equal to 1. And what's the center? Well, we just said that the center is the origin, so that's 0, 0. It's sort of very similar to the last example, except that our radius is different. So let's substitute everything inside our formula. So we have x minus 0 the whole squared plus y minus 0 the whole squared, which is equal to r squared. In this case, r is equal to 1, so 1 squared is just equal to 1. Again, as I said before, you don't need to write zeros with your y's and x's, so you're just going to write x squared plus y squared equals 1. And this is the final equation of the circle here on the graph on the left. So let's try another example where we don't necessarily have a graph to use. So this is going to be another really, really quick example. We see that the center of a circle is equal to negative 6, 5, and the radius is equal to 5. The general equation of a circle is x minus h squared plus y minus k squared, which is equal to r squared. Now in this case, our center is negative 6, 5, which means h is negative 6 and 5 is k. Now remember, when I told you when you're substituting it back into this formula, you're going to want to sort of reverse the signs. So we're going to write x plus 6 squared. So as you can tell, the h is negative 6, but we're making it plus. Plus y, so k is basically 5, so we're going to write minus 5 squared, which is equal to r squared, and r in this case is 5, so the radius, and that 5 squared is equal to 25. So that's it. This is honestly just the simplest equation of a circle with the center of negative 6, 5. So when you look at an equation of a circle too, you should be able to tell the center by just reversing the sign of the h and writing that in coordinate pair with the reverse of the sign of the k term. So this is sort of like a simple word problem question that we're going to be doing. It's not necessarily a word problem, but it's sort of different to the previous examples we've done. So they've given us that the endpoints of the diameter of a circle are 0, 0, and 6, 5. So endpoints of the diameter, what does that mean? Well, you know in a circle that the distance, or like sort of like a line from one point to another point, is the diameter. And the distance of half of the diameter is the radius. So you should probably know that from basic like circle geometry. And so basically the diameter is this whole entire thing. They're saying that the endpoints of the diameter, so this point over here and this point over here, are given two coordinate points, 0, 0, and 6, 5. And now they're asking you to write the equation. So it does seem pretty sort of as if they're giving us lack of information, but there's actually way more than enough information for us to do this. Now, before you guys start this, I would recommend that you go check out my 2 videos on the midpoint and distance formula. And so you'll be able to have a better understanding of what we're going to be doing here. So the first thing you're going to want to know is that the center point of 2 points on a diameter will always be the center. So let's say we have this point over here and this point over here on a circle. The center point will be your center. So basically what we're going to try to do is find the midpoint of these 2 points. Now, if you remember from one of my past videos, how do you find the midpoint of 2 certain coordinate points? There's a formula. So it's x1 plus x2 over 2, comma y1 plus y2 over 2. Our points here are 0, 0, and 6, 5. We're going to want to assign each of these points. So we're going to make this x1 and this is y1. This is going to be x2 and this is going to be y2. And now let's substitute everything back into our formula. We're going to get 0 plus 6, so x1 plus x2 over 2, comma y1 plus y2, so 0 plus 5 over 2. If you simplify this, you're going to get 6 over 2, comma 5 over 2, which will just be simplified to 3, comma 5 over 2. Now, let's write this information on the side. This coordinate point we have here is the center of our circle. So the center of the equation of the circle that they're trying to ask us to find. Why? Because as I said before, the midpoint of 2 endpoints of the diameter of a circle. So this point over here and this point over here, sort of that midpoint will be your center. And remember, to write the equation of a circle, 2 major points of information we need is the center and the radius. So now that we have the center, let's write it off to the side and try to figure out how to find the radius. Okay, so we've written our information off to the side that the center is equal to 3, 5 over 2. Now, we need to find the radius. How do you do that? Well, again, a simple circle, so this would be a simple circle that I've drawn over here. The 2 points of the diameter, so this point over here and this point over here. As I said before, the midpoint between these two, so this point would be your center. Now, another important thing that you should know for circle geometry is that any line from the center to the edge of the circle is the distance, is the radius. So that distance would be the radius. So this line, this line, this line, this line, they're all different lines being drawn from the center of the circle to a point on the edge or the outer lining of the circle. And those are all the radius. The diameter is 2 times the radius of a circle because, as I said before, the distance from the center to the edge of the point is the radius. And this distance would also be radius. So technically the distance is just 2 of these radiuses added up together, these radii added up together. So d is equal to 2r. Now, if you know d is equal to 2r, then that means all you have to do is find the distance of d and half it. In this case, we know that our diameter is our endpoints of diameter are 0, 0, and 6, 5. So let's say this is 0, 0, and let's say this is 6, 5. I know they don't look like this on a coordinate plane, but this is just for reference. This whole entire distance is your diameter. But we want to know the radius, so we're just going to find half of it. How do you find half of it? You find the distance from one of the points to the center. And the center, as we've given here, is 3, 5 over 2. So now we're going to be using the distance formula to find the distance between the center of the circle, as given over here, to this endpoint, so 0, 0. So let's use the distance formula. Okay, so I've written the distance formula over here. As I said before, check out my previous video on the distance formula if you don't understand this, but we're just going to be substituting these values into the formula. So this is going to be x1, this is y1, this is x2, and this is going to be y2. Let's substitute everything in our formula. So d is equal to x2 minus x1, so 3 minus 0 squared, plus y2 minus y1, so 5 over 2 minus 0 squared. So it's the square root of all of that. So it'll basically be 3 squared plus 5 over 2 squared, which is equal to 9 plus 25 over 4. Now to simplify this, 9 plus 25 over 4 would just be, if you add them up, it's going to be 61 over 4. And that is your distance. Again, you can always simplify this to become the square root of 61 over 2 by just taking the square root of the denominator, which is 4. So it's just going to be equal to 2. So that's how you find, so this final value, this is our distance. Now, we have not finished the question. There's still quite a bit more to do. We need to put everything together. This is our radius, because it's the distance from the center of the circle to one point on the outer edge of the circle. Now let's put it all together. Okay, so I've written the final equation of a circle here, and now we're going to substitute our values. We know the center is 3, 5 over 2, so we're going to write this as x minus 3 squared plus y minus 5 over 2 squared. As I said before, we're reversing the signs so that we put them in the equation. And we want to do the square of the radius, so that would just be root 61 over 2 the whole squared. So let's simplify this to x minus 3 squared plus y minus 5 over 2 squared, which is equal to, you're going to want to basically find the square of root 61 over 2. So it's technically like doing square root of 61 squared over 2 squared, and square root of 61 squared is basically square root of 61 into square root of 61, which is just 61. So it'll be 61 over 4, and that's going to be our radius, which we already found out before. Or the square of our radius is what it is. So we're going to put this value back in our equation, so 61 over 4, and this would be our final equation of the circle. So comment down below any questions you may have. I know this last example was a bit confusing, but comment down below any questions and I'll try to clarify all of them.